Okay, in this video, I'm going to give you a run-through of the shared assumptions section of the workflow. I'm going to start by showing you the geometry section here. It's divided into two parts, one for radians and one for energy plus. We've done that because radian requires a lot more details about the window and the frames than energy plus does. So you can see here we have a lot more B-reps in the radians section. We've got floors and walls and everything. I can just show you what it looks like if we go into the Rhino phase. Here, you can see you have a very detailed window here with the sills and the frame and the outside part here. I'm just going to turn this off again, like that. And then the energy plus part just does floors, internal walls, external walls, and the ceiling. You see, this is just a box office. Yeah, so that's what the geometry looks like. That's just because they require different inputs, the two types of software calculation engines. Then we have the weather file over here. This has to be in EPW format. I'm using the design reference year file for Copenhagen. And then we have the BSDF files, which is the bidirectional scattering distribution function files, which are the ones we're going to use for the calculations. We have two different formats. XML for radians. You can see here we have all of these are for daylight because it's an XML file format. And in the IDF format for the energy section because that's the format that Energy Plus uses. The last part of the shared assumptions section is the shading schedules, which we use to create the dynamic shading. We do that by making a test surface over here. We create a 1 square meter surface that is placed directly on the surface of the facade of the building, and then we measure the amount of radiation on that surface and use that to determine whether or not the blinds should, the dynamic shading should be activated. We create our test points here based on the surface on the facade, create an analysis grid and the recipe, and then over here we run it. I'm going to double click these two toggles to run the analysis, and I'm going to pause it while I do that because it may take a while. Okay, now the analysis is done running. The output from our radiant analysis here is a list of hourly values for radiation on the test surface. Using this component, we pair those hourly values with all the hours of the year so that we can create a schedule from it. Here you can see when the sun rises, this is January 1st at 9, we start getting some radiation on the surface, and then the sun sets again at 3. So you can use that data. We are going to plug it into this component, which we created here at MicroShade, and that uses our radiation data to create a binary schedule. The binary schedule is created based on this threshold value over here. So if the value is higher than the threshold value, it will give a 1, and if it's lower, it'll give a 0. And a 0, you can see the list over here, means that the dynamic shading is not activated, and a 1 means that it is activated. And so we create the schedule based on that. We can visualize it using this component here. Just click Control Q, and you can go into your Rhino environment here, and you can see it. You have the months of the year and the time of day. White is activated shading, and black is inactivated. And that was a quick run through of the shared assumptions in the workflow.